Good morning, and thank you for joining us on today's Biomass Magazine webinar titled Drax Biomass, Our Digital Transformation and the Data Behind Our Day-to-Day Decisions, presented by Data Park and Drax. My name is John Nelson, and I'm joined today with Patrick Mundy. He's the business manager at Data Park, and we also have Doug Harvey. He is the technical manager at Drax Biomass. So we're excited to hear their presentation here in a couple minutes. Before we get started, I do have a couple housekeeping items I'd like to talk about. We do want you to ask questions, and so we will hold the questions and answer them at the end, but if a question does come up on a certain topic, we ask that you, on the right-hand side in your GoToWebinar meeting, there's a questions tab. Just type in there and we'll make sure we answer it. We don't get to all the questions, we will follow up accordingly. So please type in questions and we will answer those at the end. The other thing I'd like to remind everyone about is this webinar will be recorded and will be posted on Biomass Magazine. So if you do want to review some things or want to share it with others, by all means, please do. We will have it posted probably within 48 hours of this webinar being completed, and you will be able to go back online and review it with colleagues or for yourself. So without further ado, I'm going to hand the phone over to Patrick Mundy and let him chat a little bit. Patrick.
Thanks, John. My name is Patrick Mundy. I work for Capstone Technology, and I wanted to walk you through a little bit of an overview of Data Park before Doug talks about the application of Data Park at Drax Biomass. Capstone Technology has been around for 40 years. The first couple of decades, the principals of the company worked for an operating facility in the paper industry. Excuse me, and they needed a data historian and data analytical tools to be able to do their job better. They were concerned with safety, reliability, production, and quality, all the kinds of things that all processing facilities are interested in improving. So they were there for a couple of decades. They went out into the industry, couldn't find a really good historian instead of analytical tools, so they built one themselves in-house. And it was so successful that they went on to implement it at multiple sites. A couple of decades later, they jumped out and formed Capstone, but they continued to be process engineering support for those sites and remain so even today. So Data Park is the tool that emerged out of all of that. Is a real-time data visualization and analytics package, and it really is effective for the front line, and we'll talk about that a little bit. But we have over 800 sites around the world in 25 countries. We're headquartered in Vancouver, Washington, and we are a Voith company. And Voith was founded back in 1867. They're headquartered in Heidenheim, Germany. Paper machines, hydropower, turbo, and digital ventures, about a $5 billion in sales company in 60 countries and 20,000 employees. So a little bit about Data Park. It's like I said, a process monitoring tool. It has data integration to multiple data sources. We do real-time monitoring, graphics, dashboards, notifications, and those notifications come through email and texts with links back to the system about what it's notifying you for, so that you can quickly see and access what it's trying to tell you, what might have gone wrong, and give you context for how you can proceed to address the situation. Calculations and analytics. Calculations are client side. Calculations are very quick. We also have server side as well. But analytics come with it too, so that you can do some quick analysis right there in the real-time realm. Event tracking with SPC, SQC, Pareto, control charts, those kinds of functions. We have a way to track quality, and actually a lot of customers use Data Park MDE as is their LIMS system. So but we also point to LIMS systems as well if you already have one. So it allows you to bring process and quality data together on the same screen very quickly, very helpful. In the modeling realm, we had the ability to generate PLS and PCA models. The PLS long time has been used for inferential property prediction in some other mechanisms, and then the PCA helps to model an exemplary operation that you might have had in the past and that you want to mimic that operation going forward, and it helps you to identify any offending variables out of your model set for the current operation. We also have a reporting tool with a scheduler and remote and mobile capabilities. So what sets us apart? Well, the system was first conceived and designed to connect to multiple data systems. So the process system, wherever your process data is and however many places your process data might be, we connect to that. We'll connect to the LIMS system if you have a LIMS system. It will connect to the ERP or SQLs. Some places connect to 40 different data systems that was essentially unmanageable previously, but now is manageable by these connections. And then all that is behind the scenes, and the tool then operates as a single tool by which it's essentially seamless. Nobody really has to know where the data is actually coming from. And then we have the #1 multi-trend as graded by our customers in the industry. And that means that you can put a matrix of trends up within just a couple of minutes, in probably you're looking at 100 to 120 tags if you wanted to, often 50 or 60 tags on one screen. It gives you that wide view of your process from end to end to help you understand that if you're having an issue in one area, is that an effect of the issue, or is that the root cause of the issue? So it allows you to quickly move to find where your issues might be. And we can train any staff in 5 minutes to build this thing. So it's a multi-trend is not often found in other technologies. And where it is, it's extremely difficult to put together. We have also great tools at fingertips. So just a right click often gets you the ability to add a calculation or pull data to Excel, or generate reports or notifications, these kinds of things. Very quick to be able to get to good tools. And then fast data. We have a data speed engine. Some of you may know about Hadoop in the industry, open source map reduction technology, which speeds data to the user. This is the same kind of idea. So it's we call it PARC PDE, Performance Data Engine. And so it gets the data to you fast, whether you're looking at a year or 2 year or 3 years of data down to minutes. We'd like to say click, boom, click, boom, click, boom to get to your data and make your decisions as you walk through the process of understanding what's going on in your process. And then ease of use. It's pervasive throughout the system, and a lot of the key functions that DataPark provides are very easy to build and to use. And then this allows the compression of work tasks. And so if you could imagine compressing your ability to do your work and get to your answers quicker, it actually adds manpower to your staff because the tool it allows you to move that fast through the processes. We also are a lower total cost of ownership as well. Once you get us in, we don't ding you for other things along the way. And so that's been very beneficial. A lot of customers call us, that being one of the principal reasons why they call us. And then also we typically have a short project timeline, 4 to 6 weeks. If you're ready with a server and a couple of small things in place, we can go in and have the system up and running and staff trained to use it in a very short timeline. So these are all the kinds of things that set us apart at DataPark. And so just a real quick look at some of our key customers. You'll see that we're across multiple industries. Pulp and paper has a big list of customers. That's where we got our start, but we have very key relationships and customers in chemicals, ethanol, mining and minerals, power, oil and gas, food and beverage, manufacturing, and other areas. I just wanted to point out just a handful of customers here. Of course, there's Drax Biomass. They're going to be presenting today. W.R. Grace Chemical is another key customer of ours, the Dow Chemical Company that I'll point out. Saudi Aramco's S-Oil refinery in South Korea, and Energy Transfer. And so just a little bit about these. W.R. Grace has installed data park at 6 of its facilities. We have 4 here in the States, 1 in Canada, 1 in Germany, and 1 about to install it in Brazil. 400 facilities at Energy Transfer, and they're doing a massive amount of work, and over the last couple of years have just about they've done most of their installation across those sites in 90,000 miles of pipeline as well. In 2016, the 4th largest refinery in the world, the Saudi Aramco S-Oil refinery, completely switched out their 20-year system, the current 20-year system that they had in the refinery. It's one of the top systems in the world. They completely switched that system out to Data Park because they needed performance, ease of use, a good tool set by which a larger number of staff could adopt and use. At Dow Chemical, we're doing work in some 25 facilities there, in Drax Biomass, multiple facilities. And just one last thing, Energy Transfer has done some presentations, and you can go out and find those on the web, but they're claiming $17 million a year in benefit for the installation of Data Park and how they are using it there. And then my last slide here, let's see, is just a quick overview of the Drax Biomass Amit Bioenergy Gloucester, Mississippi site. It's a typical type of wood pelleting operation setup that you see across the globe. And I'm going to hand it over now to John, just to give you a reminder, and then Doug will step in and begin to talk about how Drax has applied Data Park. By the way, at the end, we will show a short 2-minute video that will give you a real look, not only at the tool, but how the tool might be used and how a person navigated through the tool to solve a problem. It's a 2-minute video there, and we'll show that later on. John?
All right, thank you, Patrick. Thank you for that rundown. It's extremely informative and giving us kind of a quick overview of what you guys do and some of the benefits you guys have. You know, and then looking at the 400 facilities and Energy Transfer, I was not aware of that, so that was pretty amazing. So, one thing we do want to remind our attendees is, you know, please ask questions. We do have the questions tab on the right side in your GoToWebinar box, and so if you can ask questions there, we will be answering them. So, with that, we will hand it over to Doug. Doug, please take it away.
So good morning, everybody. I'd like to thank everyone for coming and giving me the opportunity to share our journey. So I am the technical manager for Drax, which is just a fancy way of saying that I focus on how we do things at Drax. So when I talk about Drax's journey, I mean, it's really similar to that of the pellet industry. It is, we're still a growing industry. I was originally in pulp and paper, and it was, pulp and paper is a very mature industry. It is one that is, it's 100+ years old. It's you have all kinds of resources and things you can lean on, but with biomass and pelletizing, it's still very new. So I mean, we're all learning and growing together, and I applaud Biomass Magazine for putting things together where it brings producers and providers to the table, because I believe that's where we as an industry have the opportunity to make step changes. So I'm going to advance my slide. So let's talk about Drax as a whole, because it's an incredible story. Drax was the last coal-fired power station to be built in the UK, which occurred during the 1970s. And at one point was the largest power station in the UK. And now for Drax, we're completely off coal as of last year, and we're a key part of enabling a zero carbon, lower cost energy future. And we have three focuses. So we're a UK-based renewable energy company. We focus on renewable power generation, the sale of renewable electricity, and for this side of the company, production of sustainable biomass. So let me see if I can go back one. So today we represent approximately 8 to 10% of the power consumed in the UK. We consume approximately 7.5 million tons of pellets each year to make that happen. Last year, the three plants I'm about to talk about with you were essentially 1.5 million tons of that. And that really consists of this footprint. So we're headquartered out of Monroe, Louisiana. We ship everything out of Baton Rouge, Louisiana. And that's really through the main three plants that are in Bastrop, Louisiana. So that's going to be the top of the map there. Then you have Urania, Louisiana, and Gloucester, Mississippi. If you don't know about Drax already, I'm not going to fault you for not knowing where many of those are. If you look over there to the far right, you'll see Aliceville, Alabama. As part of the Pinnacle acquisition that we recently completed, we pulled that facility in. We've also pulled in some additional Canadian facilities as part of that, but just for the sake of today, I was going to focus on the Southeast U.S. operations. We'll talk about it a little bit at the end, but we also have some satellite plant locations that we'll bring into the mix in the near future, and we'll also have a Demopolis plant coming on in the future as well. We'll be commissioning that here soon. So we'll talk about how we make pellets. So we have three sources of feedstock. We have the hog fuel, which is our bark. We have residuals, which come from a mix of sawmills, which could be chips that come off their process. It could be planer shaving, but it could also be round wood, what traditionally people think about whenever they're thinking about what comes into our sites. So a full-size tree goes through a chipping process. We'll take the bark that's coming off of there, we'll put it in its pile, which is what you will look like in the middle picture there. Hey, Patrick, if you don't mind, I think I may be getting some feedback through your line. I may need you to mute. Hearing the echo. So you'll see the bark in the middle there. That's what we take when we're chipping there. And the picture on the right is where our chips go. So I mean, it's a very process has very little waste. So we'll take the fuel that's in the middle picture, we'll end up burning it, we'll take the chips there on the right, and that's what's going to ultimately be our feedstock. So not a lot of additional processing variables matter at this point, other than making sure everything is running. And so at this point, we're really focused on our maintenance. So this is not really the process we're monitoring from a process standpoint, but we'll get to that here in just a moment. So not all of our mills have this first stage of sizing, but we do have wet hammer mills at a couple of our mills. So this is where we'll size just ahead of the dryer. This is what we'll call these large resizers. So chips are taken and broken down to a smaller size. We like consistency going through our dryer. Like I said, this is not always available. So we send these chips to our dryer island. So these are rotary tumble style dryers. That hog fuel I was describing in the previous process, that's where it's fueled from. So we have induction draft dryer, large ID fans pull the air through the system. So we take these chips that start about 50% moisture, and by the time they exit the system, they're approximately 10 to 12% moisture. So a huge evaporation mechanism here. So then we have our secondary sizing, and it really is the final sizing. So it's a hammer mill, just like the previous picture. We'll go through and just go into the next stage, go to pelletizing. And really at that point, we just have rotating dies with stationary rollers, and it's really a compression. So people ask like, hey, well, what are you doing there? Some people add steam, some people add sometimes a dry additive, but you're having a lot of heat there. It's really a function of the natural lignin, which is really an organic polymer that's present in the wood, and heat and pressure. So you're taking this wood fiber, pressing it through a hole. If one of my people on Drax is listening, his favorite way to describe the process is you take wood, you chip it, you dry it, you beat it up, and you push it through a hole. And that's his version of describing the pelletizing process, which is not too far from a very accurate version of it. So we take it, and we've taken this pellet, and we've got all the way down to 6% moisture. So as we were talking about earlier, we're starting around 50%, and we've finished around 6%. So loading out and shipping it, we are, depending on where the plant's located, we're doing a mix of rail and truck. And we're taking these to the Port of Baton Rouge, with the exception of Aliceville and eventually Demopolis, which are going through Mobile, Alabama, and those are going straight through to a lake can. But everything else we have going through Baton Rouge, where we do have a port location. And then we're going to the UK through where we have Liverpool, we have a Port Tyne. So when you look at what we're doing, so hey, why do we pelletize in the first place? And ultimately, it's about shipping. This is about density, because we have a small biomass plant there that ultimately does the reverse process of what we're doing here, and gets it back down to a dust form and puts it in the boiler in the UK. So let's just keep in mind that this is just strictly for shipping. So you're talking about the high-level business objective as we look at a beautiful picture we have of the Morehouse site in Bastrop. Our goal is to be a leading producer of wood pellets from sustainable, low-value commercial forestry residuals. Would like to add that we do have the world's leading sustainability program, and we do take a lot of pride in that. And our pellets are to provide a sustainable, low-carbon fuel source that can be safely and efficiently delivered through our global supply chain. And then we use these pellets to make flexible and renewable electricity for the UK. So now we talk about our process and how we make decisions. And it's important to also talk about where we started. So we talk about our data management. Data was entered into manual checklists that we then stored into a collection of file folders in various locations. We had multiple spreadsheets that were also maintained in multiple locations. And we kind of moved into the technology piece. We had a historian that was painfully slow, and for each plant location, it was accessible at only one station in the plant for 2 of the sites. We did have a little bit better version at one of the other sites, but it still was had its kinks as well. And poor detail for the data that was accessible. We had no regular exports or data syncing, and the visibility of the process from the outside was remote access to live screens. And when I say that, I'm talking about access at the HMIs. So, and that's where somebody can go in and literally press a button that the control operator, room operator is looking at. People with nefarious intentions can do terrible things in those scenarios. So you also look at our people and processes at those times. People were unable to rely on historical data, just recall. So you go through and you're trying to do an RCA of an event that happened, and you're not able to pull the data. So you're trying to go through and figure out what happened, and you pull the guy off shift. You start talking about it, and you're looking back at, you don't have to, you're looking back at the HMI and like, well, hey, I think it was 640 degrees, or hey, I think it was this. I think. And at the end of the day, we were not providing our people with the tools to be successful. It was a very reactive environment. So this I put a picture of my old historian there. We didn't even have descriptions for a lot of our tags, and I still have access to my old trend at that time, and I was trying to see how long it actually took me to load some of the data points, and I remember looking back at some of my old notes. I'm a guy who keeps old notebooks, and I remember it took on average just to load the screen to load the data points and tags. And this discourages people from digging into the data to solve the problems. And you will not get to the root cause of your problems in this environment. I firmly believe that and witness that in action. And root cause analysis without data, it will only leave you with testimony. And our availability was low in those days. We were definitely in a maturity, we were low in the maturity point as far as our journey. And when you don't have good data relative to where your downtime is, where do you focus your efforts? You tend to focus on your big rocks, but you don't focus on the death of 1,000 cuts in those situations. For example, our quality data was tracked and accessible over the radio or via paper copy. So it wasn't being used consistently to make decisions throughout the shift, or it wasn't even being pushed to a centralized source to share with other plants. And for me, slow data is equal to no data, because in that situation, it will not be used. So our current state, share the picture of our current architecture with the data park client. So currently it sits at the 3, what we're calling the legacy sites, the original sites before the Pinnacle acquisition, as well as the Baton Rouge site. So we have the collectors, the Talkstar OPC servers. Then you have the thick clients that we pull for site access, corporate access. So we have process and quality data at various frequencies. It's historized over multiple years over the journey, and we have it for machine part tracking. We calculate tooling usage. We have MDE reports, and I'm going to walk you through a couple of the different functions that we have for these. So downtime is now logged for each piece of equipment. We mainly focus on our pellet mills as our main piece of output for each facility. We judge how much tonnage we make for pellets. So it's definitely how we judge this facility, and this is valuable, and it's definitely something that we're putting a lot of effort and focus on. Our frontline staff are able to enter causes that our liability engineers are focusing on, and ultimately this is where we're going to focus our efforts. So if a shear pin, for example, is a 15-minute event, if you only look at it on a shift log, 15 minutes doesn't feel like a big deal. But if I look at it over a longer period of time, and I look at that over 6 months, for example, and I'm starting to see shear pin, and I look at it over that and measure it against all of that, and all of a sudden, like I said, originally I was looking at big rocks, maybe this 400-ton miss, but now if I look at it over a longer period of time, so now I'm looking at the complete picture. So frontline managers alike are engaged in its use every day, and to me, this is the biggest win for Drax with regards to data park implementation. So I say that everybody from our CEO down to the operators use this system. My finance and my HR people probably aren't using it, but everybody else probably has some version of a dashboard or a graph that they're looking at in some capacity. I would say that I generally judge by how many folders and who has a users folder. So I'll look in and see, like, hey, my pellet mill operator has a folder and he has his trends in it, and my control room operator, she has her own trends in it. Everybody's looking at their thing, and they may have a chart that says, hey, dryer troubleshooting, July 9th, and you can see what they were looking at that day. And that tells me what kind of problems people were trying to solve, what they were looking at. And it's also an opportunity to say, hey, this is what they were seeing. Like, hey, I was having this kind of problem. I can go back to that day. I can see what kind of things we were looking at. But it also shows that people are embracing data because you have regional corporate support like myself. You have the plant managers, process engineers. Everybody's embracing it, and everybody's learning from each other. Like I said, it's kind of one of those things where you don't have to reinvent the wheel. You can go and copy it. Like if I want to solve a problem and look at something, I can go find a drive. This control room operator here is for AIMIT, for example. If I want to see what's going on at AIMIT, I can go look through his folders and folders and see what kind of graphs he's built, and then I can see what's there. Then I can add a few more tags and see what he's looking at, for example. So quality data is entered constantly, and production personnel now expect and request the data. So not only do we build like this MDE right here, a manual data entry form, so you'll see where a lab technician may request, hey, I want to see this constant data on the top, for example. And so not only do our technicians and frontline personnel enter the data that we request, they may also request a change. And I put this one here on purpose, and this is where we add a tweak. So, hey, we decided to stop taking this one particular sample and take another sample instead. So this is when we're going to change the form. So, hey, we're pivoting. So we took feedback from the operators, and we're going to do something different. So that's why there's blanks on this form, for example. But it used to be in Excel, and we couldn't track and see the trends. And when quality went off, and we had to have something going on, we didn't see it. Or if you went to try to go back with an issue, let's say we had, for example, when we load a train, it takes, we ship a train out about every 5 days, and then let's say we had some bad samples at the port, and you're trying to figure out what happened. Well, you spent 5 days to load it, and then you're trying to go back in time, and you didn't have that data. You had to go backwards and look at it, and you're trying to figure it out. You're looking through those sheets in a file. This way you can go backwards. Hopefully you're seeing things beforehand, and that's where also the alarms come in place. So if I get some of these numbers that are in red or below alarm that I've set, I can get emails about it. There's reporting functions that come out here that email me reports that are how the plant's doing each day. It can also send me out of spec numbers, not just a generalized report. It can say, hey, I had this much out of spec when I'm looking at quality data, for example. So our morning meetings are run from displays built from Part Designer. So if you can look over here, we have availability numbers on day shift for LaSalle. So there's a display that's put in the middle of the plant, and it talks about how much material we have on our chip pile, how much material we have on our fuel pile, and this is what we run our meetings from. We talk about availability misses, what tonnage miss, and that's what the team runs from it. And it's dynamic data, and if you want to drill into it, you have the ability to do that. And that's what I was. Go back in time a little bit. I was plant manager when we started doing this, and this was one of my big asks. Was that we run our meetings from displays like this. So if I said, hey, okay, we have a quality issue, or hey, we got something going on with our hammer mills, and we can drill down into this page and we can go into exactly what's going on with the hammer mill. Okay, I don't have my hammer mill through pit. Okay, there's 3 hammer mills down. And if I have 3 hammer mills down, then I'm hoping my maintenance manager is going to tell me what we're doing about that today. So you get to keep drilling down, and like I said, it's there laid bare, for example. You get to talk about it's what exactly is causing your problems, and you can keep drilling down. So I also talked about we had forms that went away into their file folders each day. So we also have daily checklists that are now part of the Data Park system and can send out emails if not completed by a certain time of day. So I don't want to know whenever it's after the fact that I missed something. So we have daily visible emissions checks as part of our environmental compliance, and it has to be done in daylight hours. So we've committed to doing these by lunch each day. So this is a method 9 type inspection. And so if this isn't done by 2 o'clock each day, it sends out an email to the plant manager, the environmental manager, and says, hey, we have not done our visible emissions check. So if by 2 o'clock, I still have time to do something about it. So this is also one that we're really excited about. We have the opportunity to do some additional modeling. So we're currently doing some proof of concept using part model, PLS for predicting key process variables. And one variable being modeled is our dryer outfeed screw rate. And we're seeking to understand how to remove barriers and really increase production, identify what process values are slowing down the entire process. And right now we're focusing on one dryer and just trying to figure out what correlates, what we can do, and then essentially build a model around that. And that, ultimately that would be what our operator would be focusing on. But we're also adding some remote pieces to this to where our UK team can also see some of this as well, because we have a team that's modeling data from we're calling it the forest to the furnace. And so what that means is we're looking at process variables that start all the way from the forest. So what impact does feedstock selection, how we feed the dryer, how do we do, what is our fines impact, what is how we run the dryer, what does inlet temperature mean, and how does that translate once we actually put it in the furnace and produce electricity. And this is part of that process. So we're embracing that in multiple levels, and our UK team, through some of the remote access to Data Park, is able to access our data and able to produce some pretty incredible models. So our benefits case, and I'm sure I'll miss some here, and I hope Patrick will remind me of something I may forget. But root cause analysis is probably also one of the largest benefits as well. When you don't have a clear look at historical data and a lot of it, and all you have is people's testimony, as we talked about earlier, and what they thought they saw, you are at a disadvantage. Access to the data with good tools lends itself to find the true cause. And Data Park allows us to know the real problem when it happened, instead of having to listen to somebody's word. Tools greatly compress the amount of time to ID and fix a problem. So when I go in and dig and show it and reveal it to everyone, and then we all align around it, and it makes us look and dig deeper and ask questions, and it reveals itself. Because at the end of the day, I mean, recollection's faulty, and it's not negligence or ill intent; it's just faulty. So this is a great tool for all of us, myself included. We all have that mistake where we think we remember something and then we look a little bit deeper and it's just not the case. This is a tool that we owe the people on the front line. So cost benefits, and just for one of them is like we are a company that has used additives. So when we add a new additive, we can quickly determine its effect. We can look at when we change dosage, we can look at the time when we do it, and we can track the process as we added it. So it just gives a better effect to whenever we push that additive, when is it doing its job, and is the effect linear? So we can change, we see when we did the change, what was the effect of the concentration. I did talk to remote capabilities. That's part of how we can have so much access to people that are not at the plants. When we think about whenever COVID happened, and there were we definitely had frontline personnel, but myself as corporate support staff, that I tell people all the time, my job is to support people who make pellets, and part of my job at that time was also to stay away from people who made pellets, unless that was just in a dire situation where I needed to be there. But remote access allows me to do that and still be able to go in. So, I mean, I'd have times where somebody would call me and say, hey, can you see what's going on with this at the dryer? Can you be a second set of eyes and take a look at this? The remote access was something that allowed me and many others to do that. So the personnel use. So being able to look in and not have to be tied to one engineer station and be able to take a look, which is kind of a version of what we were just talking about. I mean, like I said, when we were talking about quality before, it used to be where we'd call it out over the radio. And this is another version of giving people access. I mean, we actually want to see more of this, where we have more field access. There's an opportunity to build this in just more pieces. I know Patrick talked about this earlier about data speed. This is just so important. We do have the stored data. We build in calc tags if we think that if we want to have something that's going to pull for a significant period of time, so we don't want to have to do the calculations ourselves. We just actually go and just build another tag. It's like I said, one of the reasons we didn't have adoption of the previous system was because of the speed, and we're remoting in and just having access to that system to where we get a 3-second range, and sometimes the slowest is a 10-second. I said it's just completely night and day difference. So we do our OEE within Data Park, and it's one of the things that we're putting more and more of a focus on. And to have that tracking within our system, we have one of our engineers, Sam Keaton, is really, and I know I'm the one talking to you about this today, but Sam is the one who's really putting a lot of effort in making sure Data Park sings for us. And he's done a lot of work with the modeling and putting OEE together for us. But we are tracking OEE on this side, and he's actually done some creative calculating and really looking at OEE for different streams, for example, on things that you wouldn't necessarily think would be OEE, and just looking at that as far as just a process. So modeling as well, we hit on that a little bit earlier, but like I said, we're really excited about what that could be for us. So looking forward, we talked about technology, around the Forest to Furnace initiative, the park model, and our embrace of data science. And we have a large team around that on the UK side, and really looking at the different things that we can tweak, and also just looking at what correlates from, you know, what thing can I change or invest in on this side of the pond. So we call like focuses something on the US side that hopefully translates into results on the UK side, and what that can mean for us as the whole Drax group. And then for investment, you know, we have our satellite plants in Arkansas that will start to come online relatively soon. The commissioning of our Demopolis, Alabama plant, integration of Pinnacle. It's been really exciting to where we were a 300-ish person company back at the first of the year, and then the announcement of Pinnacle, and literally a little more than doubled the company, and pretty much doubled the capacity of pellets. And then we've had several expansions of our existing facilities over the last couple of years, which has been really exciting. And then innovation. We have a viable fuels group that is looking at all kinds of things that you can burn, as well as woody biomass, X, which is one of our versions of carbon capture, as well as just other forms of growth. So it's exciting to be a part of Drax at this part in time. I do appreciate everybody listening in. I know Patrick talked about a video he wants to share with you guys before we go into Q&A.
Thanks, Doug. Very thorough information and presentation. It has spurred a lot of questions. So again, if you do have questions, please pass or enter them into the system here. We are looking at them. We've got quite a few to go through. So we will do this short presentation video, and then we will go into a bit of a Q&A.
Yeah, John, and if I could set that up while
Sure.
Tammy's putting up the video.
Sure.
This just gives you a quick glimpse at one track of thought about how to solve a problem. There's a steam flow signal that looks obviously erroneous, and so the engineer is going to do a little bit of investigation to see if it's the signal or if the equipment is actually operating that way and the signal is correct, and then and maybe a little something that they can do about it to help out. So if you roll the video, I guess I wasn't talking there for a second, but he's looking at the steam flow there. There's the erroneous signal on the multi-trend. He's going to go back and forth and take a quick look. He's going to take a look at a 7-day trend on that guy. He's already synced up the rest of the trends to find out that there's nothing else that indicates it's the equipment. So right now he's pulling on correlative variables. He's going to generate a PLS, see if he can generate a PLS model of that steam using surrounding variables like condensate and et cetera. So he's pulling up the modeling tool now, doing the PLS session, and has generated a model. 0.89 on the model is very good. He's looking at the 4 inputs to that model. They all look like equal contributions, so he's not going to remove any of those. Going to take a quick trend pop up on that guy, and it's that 6th trend down there, that odd color looking one. So he's going to get rid of the modeling tool now. He's going to take that PLS model and drag it on over to the original trend and get rid of the pop-up. Now he's got that odd color model calculation on there. He's going to change that to make it more clear, change it to red, and then change the range. And then it drops it right down on the green steam flow line. He's going to get rid of the 2 variables that he added so that it goes back to as much normal what the operator would normally look at. He can zoom in, zoom out, take a look at, and he sees that this is really where the variable should be. And he can turn the variable off, the model variable off if he so chose. So in that period of time, he pulled up the trend, he zoomed in on a certain area of a trend, he synchronized the rest of the trends so they could see if there's anything else going on that would indicate its equipment. He understood that it was the signal, and we give the opportunity to generate a signal that could, a model that could indicate what that flow is and have the operator use it. So just wanted to show you how you can navigate through a small part of what Data Park is. That's just a small part. We didn't talk about notifications and reports and those kinds of things, but hopefully that gives you a good flavor for what the tool can do.
Great, thank you, gentlemen. As we mentioned, we do have quite a few questions that we can go through here that have come in, and so I'll ask them, and you guys can kind of decide who's taking them, unless they're directed to you specifically. So the first one I'm going to ask is from Ridu. The question is, how difficult is it to integrate this system into an existing alternative system that might already exist from a different platform? For example, sorry. So integrating the system into an existing alternate system.
So for instance, I came by the way from Aspen Tech, and I worked for Honeywell, and I worked 15 years installing advanced process control and optimization around the world. So I've worked with OSI Pi and PhD and IP21, et cetera. We integrate with those systems in a number of places. As a matter of fact, that key customer list that I showed you, about half of those already had a system and didn't want to get rid of it because they had multiple staff using the history of those systems. And so what we do is we just come in and we connect to the OSI Pi or the PhD or the IP21 or the GE Prophecy or whatever the system is, if that's what they're talking about, that historian system. And then also we can connect with all the control systems, a myriad of control systems, everything from PLCs to all the DCSs. So, Honeywell Experion, Emerson Delta V, you just go on down the list, and we found a way to connect with them all. And then all those things become transparent when you use the tool. So very easy to connect, typically use industry standards to connect as well. Hopefully that answered the question. Doug, do you have anything to add?
I mean, like you said, I agree with what you said there. I mean, we had a pretty seamless transition ourselves. I mean, ours was we weren't too integrated into ours, so our transition was a little bit further. Now, this is my second run with Data Park. I came into a system where it was already there, but it was, I would say it was worth the change for us. I mean, because we were floundering in our current setup. But like you said, it was a really short timeline as well, though. I mean, even on your longer ones, you're only, like 6 weeks. So, I mean, I think when you look at, because we didn't really, there's only a short period where we had no access. So it's not like you're just in the dark in the interim.
Okay. We have another question here, just to keep things moving. You talked about, and I believe this is to Doug, but obviously, Patrick, jump in. You talked about how slow your previous historian was and how difficult it was to access data. Do you have any anecdotes or examples of how it made a difference being able to access the data more quickly?
So I will say that, the multi-trend is like a great example where, like, if I want to use a dryer trend is a great example of one where I'll normally have 8 to 10 tags that I look at. And my previous historian, me using 8 tags and building something on the fly, like I would build, if I want to build an 8 tag multi-trend right now, I'll have it up in 60 seconds. Like if I decided to do that, if I wanted to share a screen and do it, I could have it up in 60 seconds. A world where I decided to do that in the previous historian, 3 to 5 minutes to get it to load. If I wanted to go back and look at something, let's say 8.5 days ago, and get to that exact window, I'm investing at least 5 to 7 minutes of my time to do that. And if I want to do that with data apart, I could do that in probably 75 seconds max. And I'm being generous when I say that. That's 75 seconds max. And so, and that's not because Doug is a power user. That is because that's the ease of the system. I can go to any kind of mid-level user can do that. Okay, is that a fair? I don't think I'm exaggerating when I say that, Patrick.
Yeah, you're right. I like to go out afterward and see if we did, what the say-do ratio is. Is the system doing what we said it did? I went out to one before they bought, and he pulled some tags over to a trend, 3 tags over to a trend, and the trend popped up, and he said, "See, we can do the same thing you guys do." And I said, "Darn, that's pretty good. If you bring up a year, just bring up a year, just curious." So he pulled up a year. It took 3 minutes for the data to load, 3 minutes, and completely unacceptable, right? And then I went up afterward, after we installed at the site, I went up and talked to the process engineer, and I said, "Did this thing really do what we said it was going to do?" And he said, "I used to bring up a trend, just pull the trend up, and it would take 30 seconds for the trend to come up." So he's up in his office, he gets a phone call, he turns, he says, "Okay, I'm going to go look at, hang up, and I'll go look at something, and I'll call you back." Well, in the 30 seconds it took for the trend to come up, he would also maybe look over at his email because he knew it was taking time. By the time the trend got up, he forgot why he called that particular trend up in the first place. So once again, to be able to go click, boom, there's the data, click, boom, there's the data. And you're probably going to have to navigate to maybe 3 or 4 steps at times, or maybe more, to get to your answer. It really compresses down the amount of time that it takes to get to the answer.
Great. Oh, great example. Love hearing the stories too. So, this is a question for Doug. This is a 3-part question, so I'm going to take it in 3 parts when I ask it to you. And again, Patrick, jump in if you want to add anything. So, the first question is for Doug. Could you give more granularity on your cost per ton equivalent on the described pelletizing process? What it is for feedstock production, or feedstock production, for example, drying and shipping costs, logistics in the U.S. for rail and port costs, and costs of shipping to Drax. That's a very big first part of the question. So if you want me to repeat it, I can.
Yeah, let me circle back to that one, because let me look at how much of it's versus Drax information versus. Let me make sure I'm not giving away anything that's not,
Sure. And if it's Right, right. And if it's more information that you don't want to share publicly, we can definitely answer that question privately.
Let me circle that back to that one at the end. And what's the second part of it? Let me write it down so I can circle back.
Yeah. Right. And we can always follow up. You can follow up personally too on this question.
Tell you what.
Too, if that's
tell you what. Save that one for me, and I don't mind following up after the fact with it. Is there a second part that's not financial?
Yeah, let me. It is more cost benefit, but you may be able to talk about this one. I'll ask it. On the feedstock, what is the cost benefit of using hog fuel versus chips and fiber?
So I'm guessing they're saying hog fuel in the furnace maybe versus chips and fiber. So hog fuel is probably half the cost of chips and fiber, and that's definitely available in the open market. I'd say for Southeast U.S., hog fuel could be anywhere from $10 to $20 a ton. That's a U.S. short ton, and then your green feedstock is anywhere from $25 to $35 a ton, depending on if you're buying inwood chips to sawmill residuals, and get even a little bit higher depending on what market you're in. I think you can look at any index and find that data. So yeah, that being said, hog fuel's cheap, and you're making it anyway if you're doing some chipping. That being said, if you're able to, you can use some bark in your process, and a lot of people are. If you look at some of these sawmill suppliers that are even in the Southeast U.S., they don't know what to do with their bark. Some people are barging it out. I think some mills are actually sending it up to. I've heard people sending it as far north as Chicago for mulching, and I mean, so it's truly still a waste stream. And I'm always, looking at how can we use more of it as our feedstock, for example, because it's relatively inexpensive without driving up our ash content. So it's a great fuel source. And also, if we're also looking at our greenhouse gas footprint, so if we use natural gas, that would ultimately go the wrong direction. So ultimately, this is this product that we're creating, surplus of it out there. So that's why we try to use it. And like I said, if we use too much of it in our feedstock, we would have all kinds of ash, and then you start having quality issues with your feedstock as well if you use too much.
Okay. And you kind of got into this, but it goes along another question from another listener. They said, "Can you please define hog fuel?" And obviously, you're talking about chips and bark and wood fiber.
Yeah, but bark. When I'm talking about hog fuel, I'm talking about exclusively bark.
Right. Okay. All right. And then the third part of the question, again, if this stuff gets a little too sensitive on the financial side, we understand. So we can follow up personally. But what are the cost-saving opportunities that you still see are available from optimization from using Data Park? And then the question that came up is, did Pinnacle use the same system?
Pinnacle is not using the same system. I think our opportunities are really around efficiency. I think that this process is it's a very crude mechanical process to make pellets. And I think as you drive efficiency, so we're talking about modeling around our dryers, for example, when I look at how anytime I can reduce the standard deviation in a process, I become more efficient. And as I do that, I drive cost out. As I drive variability out, I drive cost out. And so, because ultimately that's reduced energy consumption. That's a opportunity to use less of any additive. Those the things like that. And I think that whenever because one of the most expensive things I do is dry wood. So things like that model that we were describing earlier, and if I can get that down to where that's more efficient, then that's going to be the path forward. So those kind of efficiencies are definitely where we'll continue to realize savings.
Great.
And I would
Go ahead. Yep. Go ahead.
Yeah. So and that's some of our customers utilize the PCA, which once again where you have exemplary operation, where you can identify that this is exactly how we want to run this thing all the time, and even when you have moving parts and pieces, but you can take this model snapshot, if you will, of that process, that exemplary operation, and then utilize that going forward. It doesn't apply in all situations, but some customers are using it effectively to identify a list of offending variables, if you will. So if I've got 30, 40 variables that I've used to model my process in this exemplary operation, and today now I'm currently operating, and it is constantly checking against that model, and it will identify when all those variables have a relationship, typically have a relationship to one another. And so those are all modeled, as well as where they should be in the process related to each other as well. So this mechanism flags in an orderly sort of way and in an ease of use way what the highest offending variable is. It gives you a totem pole, what the highest and lowest is, and then you can investigate immediately those variables in that order to identify your problems and either alter what the operators and control room staff are doing, or fix an equipment problem.
Great, thank you. Another question we have is, how long has Drax used Data Park?
Patrick, correct me, but I think it was April of 2019 when we started.
Yeah. So you guys, I want to say about a year and a half or so. Is that?
I think April 2019 is when we started the actual, putting our hands on equipment. I think June 1st is whenever we brought it online.
Right.
Okay. Great. Do you have a specific example or a story you can talk about how Drax has used data to reduce operational costs, improve OEE, or better plant safety? You touched on that, briefly in some of your slides, but can you give another example of how the data was, used to reduce costs, basically efficiency?
Yeah. So I would say that, we talk about like our RCAs, for example. I mean, when we go through and go and dig into these events and find out, what happened, and I'd say, like, when you talk about like our efficiency, generally it's like around these dryer events, or find out like, hey, we're pulling in all this air here. So one of the biggest things that you have problems with, like, is if you're pulling air into your dryer where you shouldn't be, and you go and find like these dampers that are in weird positions or something, or even if you find like where, hey, I'm looking at it and it says, hey, I'm all the way open, but you look at another setting and it's like, there's no way that's correct, and you'll realize like something's out of position. So I'm looking at it and it's definitely right, but maybe mechanically a damper's failed in an open position or something. So you definitely have an opportunity to correct those. So we've had situations like that where, hey, I'm showing a damper's closed. So, hey, I got this reading, and it shows this position. I'm looking at in Data Part, but I'm also getting another reading where I'm definitely showing where I'm pulling a lot of air in, for example. And so I go out there and verify these readings I'm having in the field. So you're doing this troubleshooting in a conference room or something like that, and you're like, okay, these two data points don't align. And I've had a handful of these situations. I'm like, hey, let's go look and let's go investigate. And then you go there and look, like, okay, this damper is obviously, something's come loose. The damper is not actually in the position it says it is. You go change it, everything comes back in line, and all of a sudden this air that you're accounting for goes back in, and all of a sudden you stop. You're talking about like a 900 horse motor that's accounting for this damper position you're talking about. Or I remember one time we were fighting with a dryer, and like, hey, where's all this? We got some kind of heat issue, or no, we were I take that back. We were trying to figure out what was going on, and we were like, hey, we're running wide open, but we're only got so much throughput. And we started looking at the heat, it didn't matter. And then we figured out, we go there and look, this temperature doesn't make sense. And you go out there and look in the field, and you're like, the chute's plugged, So it's this tool that it gives you all these additional data points, because it leads you to look at this out in the field, and these become like these huge pieces that are either big downtime pieces, big process issues. I said it's one of those where we are, like you said, before you kind of struggle and you scratch your head for days, but now I've got E&Is and control room operators or a dryer lead, and they're all huddled in the conference room staring at these screens, and it's like, well, okay, let's add this tag and lay this one over it, or let's shift it by 2 hours and see what that does. Okay, let's look at that. And then they find it, and like those dampers, or you're pulling the air in, and you've got all of a sudden 1,200 horse motors accounting for, or 15 horse motors accounting for. Those are huge, very expensive motors to run.
Yeah, and this is wrapped up in your downtime tracking as well. And maybe what's hard to understand is the practical and make sense application of SPC SQC, in which the system is set up, as Doug had mentioned earlier, that if the frontline operator sees an event that occurs, a temperature where it's not supposed to be, brings it back down, whatever, identifies it then automatically generates an event, which he goes in and selects why did that occur, and there's a root cause tree that he'll select from, and these get collected over time. Maybe it was a 5-minute event or 20-minute event, whatever. He gets it back under control. We're all good, but that reason gets recorded right there. Well, over time, you come a month out and you're like, you know what, we're seeing this pop up. You can pull up a Pareto real quick, just do a right click, drop a Pareto on the screen. It goes back and collects all of the reasons why something has occurred and presents them to you and tells you what the impact is in time, in count, and number. So it helps you to understand, we've got to focus on this one area. If we focus on this one area, we'll get rid of half of the events that pop up for this issue.
All right. Questions just keep coming in, so we do have time for a few more here. This is a question I think both of you could answer, but do you have an example where Data Park was used to transfer knowledge learned at one plant to another? Do you have an example?
Yes. I have several trends that I keep that are side-by-side duplicates of another plant. Because Morehouse and Amid are almost identical plants. They were built at the same time. So I think Amid is definitely just on a smaller footprint of Morehouse, and has just some different configurations. And Morehouse has changed a little bit over the years with some expansions, but slight differences. And they have wet hammer mills now, but their dryer, for example, is identical. They feed with wet hammer mills now, but I've laid it over, side by side and say, okay, here's where Morehouse is doing this, or hey, here's where Amid's doing this, and it's a great situation. Like, hey, if I'm seeing this at Morehouse, and let's see what's happening at Amid, and go find a situation where this is happening, where let's say my RTO is struggling with temperatures. Okay, well, Amid's here. Okay, well, what other kind of settings does Amid have in that same time? Okay, let's say I'm trying to get to 1650 RTO over combustion temperature, and let's say Morehouse is hanging out at 1625, and I'm still trying to get to 1650, and Amid's at 1675. Well, I'm starting looking, okay, what is the RTO fan at? Let's say it's at 58 hertz, and I'm up here at 62, 64. Okay, well then what other setting? I can start backtracking. I can lay that up, and I keep some of those trends because I'll save them after I build them. And like I said, sometimes I label them, hey, troubleshooting this date, or like, hey, MBE versus ABE RTO fan, or MBE versus ABE furnace, and go through those. But it's great when you can have those side-by-side comparisons. I don't always have a mirrored plant to lay that against. But yeah, that's definitely a situation where you can do that with. But we've also done that with like LaSalle, which has a completely different dryer, because it's also an opportunity to like look at something completely different. Like, well, hey, this system, it has a recycle fan that's doing this, and they use this damper to trim like this, and so you can look at that and say, well, here's where they balance it, and now they run their recycle fan like this, but you can also account for it in different ways, and they're also, and that's one thing about that condensed footprint that we were just describing. I can be at any one of when I start my day at any plant, if something happens or whatever, I can be at the other one, except for Canada, by that afternoon. And we do send today, for example, I'm in Aliceville, and there is a millwright from LaSalle here today. The last time I was in Aliceville, there was a control room from LaSalle in Aliceville. And I've had times when a Morehouse control room operator goes to LaSalle. A lot of knowledge sharing, and they'll pull up their trends and they'll share what they see, and they'll say, hey, I look at this way. A lot of that goes on, and a lot of those do those side by side trends like that because they know what the other one's looking at. I hope that helped answer the question.
Yeah, and I'll add to this. There's a number of examples that we could give, but one of them is actually in a paper that Domtar wrote and is online. You can go see it for yourself. But Jason Miller recounts there. He's a continuous improvement specialist. He says, imagine you're a process engineer in our mill in Nakusa, Wisconsin. You want to see a real-time comparison of the machine's output at your mill versus a machine run by your colleague at a mill in Windsor, Quebec, or at any of their 11 other pulp and paper mills. They have one common system that makes it possible in real time. And as Doug showed you earlier, there's a couple of different ways to get one common system. You can have server-based systems at multiple sites, which you give access to other sites. You connect those up, or you can have a central data center at your company, at which you can install Data Park, or you can install Data Park in the cloud. But in either of those situations, you're given access to be able to view other information through a highly secure, highly deliberate utilization of emerging technologies manner, so that you can see and compare your site to other sites.
Great, thank you. We have time for two more questions, and then we'll wrap things up here. So this kind of ties into the future for Drax, but this question came from Vic Hendricks. He said, hello, gentlemen. Vic Hendricks here with Steel Fab of Monroe. Gave himself a plug. Suppose I didn't have to read it, but I did. We have helped you all on expansions at both your Louisiana mills. Do you expect further expansion at these and your other existing locations here in the Southeast in the next year or so? Also, any plans to build new plants from the ground up, greenfield sites, for example? Now, if you want to make it broader, if you don't want to get that specific on this question, we could broaden it and just say, what does the future hold for Drax? And I'll kind of push it to Doug.
Well, Vic's almost like a neighbor to me, so hi, Vic. So yeah, I'm really excited for the future for Drax. I think that the Southeast U.S. is definitely an untapped. There's still some potential. It's not an untapped market anymore. I mean, we still have the Envivas of the world, and they just announced another plant that they're building. They're definitely in some of the same locations we are. You definitely see some other, some more announcements from other people as well. I mean, so it's definitely competitive. I think that we're definitely looking at those kind of opportunities all the time. But yeah, I mean, we just acquired Canada, the Canadian plants, along with the plants that we have in Alabama. But we still are trying to get to 5 million tons of self-supply. So whenever we acquired Pinnacle, that we did get to 3 million tons, but we're not there yet. So I think that I don't think we're done. As a short version of it. And I think that hey, you either grow through expansions, through M&A, through greenfield. I think all of that stuff's still on the table. But what mix that ultimately takes, I'll shake the magic 8 ball and we'll see what it says,
Right. Appreciate it. Thank you. And obviously, we're excited on any movement that you guys are doing. So we'll be looking at it at Biomass Magazine and Pellet Mill Magazine as well. So paying attention. So when we'll leave on this last question. I just want to kind of leave on, this is more geared towards Doug, but what are your words of advice for anyone considering adoption of Data Park or a similar system?
I would tell anybody that they need this system or something similar, you have to put data in the hands of your people. Because ultimately, if you don't, you're riding blind. That you have to ultimately you have to put tools in the hands of the people. Because if not, I looked at what we were doing, and this was one of my goals whenever I came on board at Drax was to give a tool like this to, because when I first came on, I was a plant manager, was to put a tool like this or this tool. I was a fan of this tool. I have no issue admitting that because I had used it in a previous life. In the hands of my operator, because I had seen what it would do, and I was excited about us bringing it on, and just really what we're using it now in a way that, in a greater way than we were using it in my previous role before I came to Drax, and I'm excited about that. But when I see people from upper management all the way to my pellet mill operators embracing data this way and using it to make decisions and asking for us to make tweaks and how can we do this? Can you add a tag for this? That shows me that people are embracing data to make decisions. That's when you get away from my gut, or everybody's heard the phrase, "Hey, this is how we've always done it." This is how you get away from stuff like that. So I would encourage people, if you want people to make decisions with their head, this is the path to it.
Great insight. Any last words, Patrick, from you as well?
Yeah, and I would, anybody that's interested, there's some other resources out there that we could send them. So if they're personally interested, shoot a note to you or whatever contact information that you give them here at the end, and we can get them the information personally. I can think of, everybody has their own style and presentation, etc. But do your homework, read a lot. I'm in sales, and obviously I'm seeking to get people interested in Data Park. But go ahead and see the demonstrations. Get people to pull up their software in front of you, and you say, okay, now tag, now add a notification, now show me how a report is done, now, etc. If they struggle, then you're going to struggle. So you've got 100 companies saying all the things that we're saying right here. Got to be able to show you is my my 2 cents there. So
great, thank you. And just quickly, is Data Park being used on all the Pinnacle plants that were purchased?
So as Doug had mentioned before, and Doug, you go ahead and answer that one.
No, we're still really going through integration of all this at this stage. I'm a little biased. Of course, I would love for everything to look just like everything I do. That's the selfish version of me talking. But that being said, I mean, we and I talk like us US guys, we're biased and we think we have a version that works. And I'm optimistic, but we think that we have a good product, and I think we're gonna definitely evaluate everything as like a true integration play, where we're looking at what's good. There's definitely great things that we've learned from the Pinnacle side too, because we definitely did acquire a great company, so we're definitely evaluating all of that, and I think as we go through all that, we'll all merge and become one, and we'll stop talking about Pinnacle versus Drax, and we'll all become one soon.
Great. Well, thank you. That is all the time we have today. We do have there were a few more questions. We'll forward those on and make sure they get in the hands of the presenters. So if your question wasn't asked, we'll make sure that they see it. Again, thank you, Data Park and Drax, for presenting today, sharing your knowledge, your information with us. I know we appreciate it at Biomass Magazine, and I know our listeners appreciated it greatly. So thank you for doing this. Just as a reminder, we have some upcoming events. We have Biomass Magazine's 2022 Editorial Outlook webinar coming up. We also have Pellet Mill Magazine's 2022 Editorial Outlook coming up, and that's with Anna Simmet. And she'll be talking about the themes and what we plan to cover, kind of the hot topics that are happening next year and what we'll be covering in those markets. We also have, and we're very excited about this, the International Biomass Conference and Expo, and you're talking about the Southeast. So there's a reason we have this event in the Southeast. It's the exact same reason, and that is taking place in Jacksonville, March 14th through the 16th. So be sure to mark your calendar for that. We'd love to have everyone on this call there and attend. And then we also have our International Fuel Ethanol Workshop and Expo taking place next June in Minneapolis, and that is tied in with the Biodiesel and Renewable Diesel Summit as well, co-located in Minneapolis at the same time. So again, thank you to our presenters, and this was recorded, and we will be posting it here within 48 hours and sharing it with everyone as well. So again, we appreciate it and have a great day.